This is exactly right.
In the aftermath of a shocking crime, people always ask why. Why would someone do something like that? I'm Candace DeLong, host of the podcast Killer Psyche, where every week I explain the thoughts, motivations, and behaviors of the most violent figures in history. Listen to Killer Psyche on Amazon Music or wherever you get your podcasts.
This particular illness started in late December 2015. And the first thing I noticed was some unexplained weight loss, which I only noticed because I had an illness about 6 years prior that also started with some weight loss. And so I was a little bit worried, but I felt fine so far. But then a few days after that, I started getting really, really thirsty. And it started with just a really dry throat, but before long, it became a really deep thirst. And I just returned from a family visit. So one friend suggested that maybe I was dehydrated from being on the plane, but it didn't go away no matter how much I drank. And I started keeping track of how much I drank. And for the next little while, it was just between 1 and 2 gallons of water every day. I just could not get enough water. After a while, I also started craving salt. I wanted chips, pickles, everything salty that I could get, which was a little bit unusual, which was probably due to all the water I was drinking. So as things went along, things just started adding to that. You know, with all the water drinking, I had some bathroom trips. It was hard to concentrate. My head felt really heavy. I was sleepy. My sleep actually was all over the place. Sometimes I had insomnia and sometimes I couldn't get enough sleep, but no matter how much I slept, it didn't help. Eventually, I started developing, I think they're called hypnic jerks, which is, if you've had this, you'll know, right as you're falling asleep, all your muscles just jerk. It kind of feels like you're falling. And that started happening almost every time I went to sleep. I just felt really unwell all the time, and I could not get energy no matter what I did. And eventually it got to the point where it was hard to stand for more than about 15 minutes. It just felt like my legs were going to give up. They wouldn't support me anymore if I didn't sit down right away. I would have staring spells because just my mind couldn't get enough energy to figure out the steps for the tasks. One time it took me almost half an hour to figure out how to make a salad. And by make a salad, I mean getting a bag of salad out of the fridge and pouring it into a bowl and putting dressing on it and eating it. Eating was really hard. Sometimes I didn't feel like it. I had no appetite. Sometimes I forgot. Sometimes, like with the salad example, I just couldn't get enough energy. I couldn't figure it out. And then there were other times where I would have bursts of hunger and I just would eat everything I could get to. I had to nap in my car after work, after I got home, before I went into the house. Sometimes I had to completely stay home from work and just rest. Sometimes on the way home from work, I would be in tears just from how tired I was. I think the worst night I remember, it was towards the end of January. And I was with some friends and getting ready to go home. And I just suddenly lost all my energy. I had to sit down because my legs were giving out. One of my friends helped me walk because I couldn't walk in a straight line. And we took an elevator down, still had to rest, sit down on the sidewalk and rest on the way to the parking lot. And I stayed at their house that night. And that was the first time I had muscle spasms. And they were in my chest. And that was scary, but we figured out it was just muscle spasms. The worst part was that I didn't know what was going on. It was scary. It felt like my body was going to start shutting down, and I didn't know why, and that was the worst part. The fatigue was just bone-deep weariness. One day, I caught myself in the mirror as I was walking by, and I was in my 30s at this point, but I looked at myself in the mirror and I was walking hunched over and slow as if I were really old. I had to take the stairs one at a time with both feet, like a toddler. I started wondering if I would eventually get to the point where I wasn't able to function at all and had to have full-time care or something. And I was starting to wonder about what kind of plans I would have to make, like if I would have to move, who would take care of me, what my life would be like if it changed that drastically. Emotionally, I was a wreck from the fear and not knowing. It was just physical and emotional exhaustion. All in all, I was sick for about 3 months. But in the beginning of January, probably about a week or two into feeling sick, I had gone to the doctor and they did a basic blood test. It came back and everything was normal except for low vitamin D and low sodium. And because low sodium is life-threatening, the doctor rightfully concentrated on that. And I think it was because of all the water I had been drinking. I just flushed all the sodium out. So the doctor put me on a water restriction. I could only drink I think it was about 80 ounces of water a day. And that added to the emotional toll because I was still very thirsty. But because of the low sodium, the doctor didn't tell me anything about the vitamin D. Eventually, I changed doctors about a month later. So this was about the middle of February by this point. That doctor didn't have any answers, but did notice the low vitamin D test results from before and gave me a prescription. That doctor also sent me to a neurologist where I got tested for everything from vitamin B deficiency to multiple sclerosis. Every single test came back normal. But while I was having all this testing, I had started the vitamin D prescription, and within 1 day, I noticed a difference and started feeling better. After all the testing came back normal, but because I was feeling better, they just decided that must have been the issue. And I have just been really careful about keeping my vitamin D levels up. Things have been okay since then. I should mention your vitamin D should be at about 30. And on that first blood test in January, my levels were 11. So it took a while to get things up to where they were supposed to be again. But everything just immediately started getting better and things turned around after that. And so, like I said, I've been really careful to make sure that I take vitamin D and try to get some sunlight because I had never been so miserable before or since, and I am never going to let that happen ever again if I can control anything in my life.
Wow. I mean, I honestly had no idea how many things vitamin D could affect. So thank you, Brittany, for sharing your story with us.
Yeah, thank you. Thank you for having to relive that.
Yeah, awful. Hi, I'm Erin Welsh.
And I'm Erin Allman Updike.
And this podcast will kill you.
Welcome to Vitamin D.
Yes. The sunshiniest of all the vitamins.
Yep.
That makes no sense. I'm not good at improv, Erin.
That's okay.
Yeah, this is our first vitamin or vitamin deficiency topic of the season. Mm-hmm. And I always like doing these topics because I think it gets us to think about health and the history of discovery in different ways than we normally do.
Agreed. I also had so many thoughts about like the evolutionary context of this hormone/vitamin that I don't think that we'll have answers to, but I'm hoping that we can at least chat about them.
Yeah. There is definitely going to be a lot to chat about. I can't wait to hear what you have to say for the supplementation guidelines and whatnot.
Yeah. A reminder that this is not a medical advice podcast.
Yeah.
We are not your doctors. And we're going to talk a lot about what other people have to say about supplementation. It's going to be really fun.
It is. But first, should we get started with
quarantine time?
Yes.
Yep, we should. Today we're drinking Vitamin Delicious.
I'm glad that you liked that one.
I really did. I actually laughed out loud when you sent it.
I was in my head pronouncing it Vitamin Delicious.
Oh, that's cuter.
And we had to include some source of vitamin D in this quarantini. And I thought we should maybe stay away from things like fish liver oils and stuff like that.
You didn't want to use some delicious cod liver oil in our... It's a much higher grade of, or higher concentration of vitamin D.
I feel like there's a trade-off there between taste and vitamin D levels. We went with milk or cream. Vitamin Delicious is basically a White Russian.
Fantastic.
Yep.
Delicious.
Delicious, which, if you need a reminder, is cream, Kahlua, vodka. Simple, delicious.
We'll post the full recipe for that quarantini as well as our non-alcoholic placebo-rita on our website, thispodcastwillkillyou.com, and our social media channels.
On our website, you can find a whole host of things. Check it out.
Yeah.
That's all I'm going to say.
That's fine. We're 3 episodes into the season. I think we're done telling people.
We're already
just
tired
go
of
there.
doing it. Oh, I do want to point out that there is a submit your firsthand account form that is new on the website that I have mentioned before. But if you need a reminder, it is there. Just go to thispodcastwillkillyou.com.
Okay. Should we get started with the actual meat of this episode?
I think we should, right after this break.
Cherie Warren was a young mother looking for a fresh start. In the process of a divorce, she'd moved out, found a great new job, and even found a new boyfriend. Life was looking up. But on a mild October evening after a long day at work, Cherie said goodbye to her coworkers, left the office, and was never heard from again. All eyes quickly turned toward her estranged husband. He had a checkered past, having lured another woman into the mountains, where he beat her with a tire iron. But there was another man that also piqued the interest of investigators, Cherie's new boyfriend. He was a former reserve police officer with a dark history of sexual violence. The two men closest to Cherie. One swore he loved her, the other seemed not to care. But did one of them murder her? I'm Dave Cawley. In Season 3 of the hit true crime podcast, Cold, I dig into what really happened to Cherie. Follow Cold wherever you get your podcasts. Hey, Prime members, you can binge the entire series ad-free on Amazon Music. Download the Amazon Music app today.
So, vitamin D, which goes by a whole bunch of names, which I'll get into in just a second, is a secosteroid or a secosteroid. I tried really hard to figure out which the pronunciation was, and I couldn't.
I like them both.
I like secosteroid. It feels correct, which basically just means this is a molecule that is derived from a steroid. And vitamin D happens to be both a hormone, which we make ourselves. A hormone is something that gets transported in our blood to a different site of action in like a different organ and has various regulatory functions, which we will get into, I promise. But vitamin D is also a vitamin, which means it's a micronutrient that is essential in our diet because we, in general, as a rule, can't make enough of it. which I find so fun right off the bat. There are multiple forms of this vitamin, and all of them have to be activated prior to being hormonally active. So there's vitamin D2, or ergocalciferol, which is found in plants and some fungi, and vitamin D3, or cholecalciferol, which is found in animal sources like fish liver oils, for example, and is used for a lot of fortification, like in our milk, and is the type of vitamin D that we make in our skin.
Right off the bat.
Okay.
Are you going to tell me the difference between these two functionally, or is there a functional difference?
Excellent question. There may or may not be differences, but since we're focusing on broad strokes on this podcast, practically, there's not that big of a difference, because both of these, if we ingest or make D3 or ingest D3 or D2, in either case, these forms both have to make it either from our guts or from our skin to our liver, where they then have to be hydroxylated into something called 25-OH vitamin D. Then they have to travel to our kidney to be converted yet again into the active metabolite, which is 1,25-dihydroxy vitamin D3, aka calcitriol. And that is the actual active form. So yes, there are differences between D2 and D3, and there's a lot of debate in the literature as to whether, is it better to supplement with D2 or D3? And there's not a hard and fast rule as of yet. But in general, they both have to be converted by a pretty similar, if not exactly the same process. And so really not a huge difference.
Okay. Interesting.
Because no matter what, whether we're making vitamin D or ingesting it in various forms, we have to process it both in our liver and our kidney for it to be active. What is this activity of this hormone, vitamin D?
That's an easy question to answer, right?
So easy. It's just really simple and straightforward.
Yeah.
One of the most well-known and important functions of calcitriol, or active vitamin D, realistically for this episode, I'm just going to say vitamin D. One of the major functions in our bodies is its involvement in ensuring that calcium levels in our blood are maintained. And calcium, most everyone probably knows, is critical to the health of our bones. So how does this work? Vitamin D, calcitriol specifically, travels to our guts, from our kidneys to our guts, where it promotes the absorption of calcium and phosphorus. Both of these are really important minerals for calcification of our bones. It also works in our kidneys, where it's actually made, to increase the amount of calcium that gets reabsorbed so that we're not peeing out as much calcium. We lose less in our pee. And then it does this weird, slightly counterintuitive thing where it also stimulates our bone cells, specifically osteoclasts, which are responsible for breaking down bone to release calcium. And that seems counterintuitive, but what it ends up doing is, in the long run, resulting in more calcium being available to then be deposited into our bones to build strong bones.
Kind of like bone renovation, or
yes,
bone remodeling, I guess would be the actual term.
I really like renovation, though. I like that a lot better. So just a little bone renovation going on.
Just a little bit going on.
Exactly like that. So in short, without vitamin D, we can't absorb enough calcium or phosphorus. Both of these minerals are essential for bone ossification. So what we end up with, if we are deficient with vitamin D, is deficiencies of both calcium and phosphorus. So unsurprisingly then, one of the biggest concerns when it comes to especially severe vitamin D deficiency is osteomalacia, or soft bones. And this can increase the risk of fractures. In children, this results in what is known as rickets. So in kids, their bones are still growing, right? So they're not fully mineralized to begin with. So what happens in a child, infant or a young child who ends up with a vitamin D deficiency is that their bones are never able to mineralize.
Mm-hmm.
So what we see in terms of both symptoms as well as signs that we look at like radiographically and on x-rays and things is that their growth plates, like the plates where your long bones and things are still growing, become really widened.
Mm.
And then we see evidence of bones that are not strong. They're not well ossified. What this results in is slowed growth. So on a growth curve, these kids will be either slowing down in their linear growth, like their height growth, or they might fall off of their growth curve that we look at how they're growing.
Okay.
You can also see really commonly a bowing deformity, especially of the legs, if the kid is old enough to be walking already, because those long bones, like your femur, are so weak that it just can't support the weight of the rest of the body. So you get this bowing at the knees. You can also see, especially in very young kids, delayed closure of the bones of the skull. Babies are born with skull bones that are not fused. And this fusion can take longer in the case of rickets because you don't have enough calcium and phosphorus to be able to mineralize that bone. And then what's interesting is that you can see this excessive growth of cartilage in the places where our bones and our cartilage meet, especially in our chest wall or in the wrists. So this results in these kind of characteristic findings that they're often called like beads on a rosary. It looks like kind of knobby beads along the center of the chest wall.
Huh.
Because the cartilage is like, you can almost think of it as like trying to compensate.
Yeah. Trying to
Right?
bridge the gaps of like where there's no calcium. Okay.
And then the same thing you can see at the wrist. So you can see actually these wrists that look wider and larger, but in fact it's because the bones underneath are so weak and small. And then you can also see delayed dentition since our teeth are also made of calcium.
Right. A lot of things.
A lot of things, and I'm not even done. If it's very severe, if rickets becomes very, very severe, then what you can see is hypocalcemia, so calcium levels in our blood that are so low that you have additional signs that are extra skeletal, so not just looking at bones, but you can have muscle spasms that are called tetany, where if you like tap in certain places, you'll see a spasm of the muscles, or even this can progress to seizures. And in worst case scenario, it can actually result in cardiac failure because calcium is also really important in stabilizing the cells of our heart. So when your electrolytes become so out of whack because you're not able to absorb enough calcium and phosphorus, then the electrical system of your heart can start to fail. And that's all just under the umbrella of rickets.
Whoa.
I know.
Okay, so historically, I had read about mortality rates due to rickets, but I had no idea how it actually happened. That sounds horrible.
I know.
I have a couple questions.
Great.
Okay. Tetany, I'm assuming, comes from tetanus?
Oh,
The
that's a good
spasms?
question. I never thought about it, but probably.
And then my other questions are about, well, one is about timing, not of rickets, but of vitamin D and calcium. So you need to have vitamin D present in order to absorb calcium, right?
Mhm.
So what is the timing of that? Like how long does calcium stay in your guts or how long, you know what I mean? Like,
Yeah.
what's the timing?
That's a good question. I'm not going to give you like an actual answer, like 15 minutes post whatever. But one thing that is important to note is that the active form of vitamin D, calcitriol, the kind that's made in our kidneys, does have a very short half-life on the matter of hours.
Oh, wow. Okay.
So we have to continually make active vitamin D. And what circulates in our body and what we measure to see if somebody is sufficient or deficient in vitamin D is that second form, the 25-OH vitamin D that we make in our liver.
Okay.
So that is kind of an important point, is that you have to first make that liver form, which then we can detect and is kind of floating around in your body in theory, or is stored in our fat cells, which is important. And we'll talk more about that later. But then it has to be converted by our kidneys to actually be active, and that active form doesn't last that long. This is all very tightly controlled in conjunction with another hormone called parathyroid hormone, and controlled by our calcium levels. So it all works in like very complex hormonal loops that I'm not going to get into. But yeah, so like if you, for example, our milk that we drink in the US at least, milk has very high amounts of calcium. We fortify milk with vitamin D, but that doesn't mean that the vitamin D that you're drinking in that milk is helping you absorb that calcium in that particular glass of milk.
Fascinating.
I know. It's kind of fun, right?
Whoa. Okay. My other question is about rickets interventions, which I assume is primarily through supplementation with vitamin D and calcium.
Yep.
How does that work, and how well does that work?
Yeah, great question. It definitely works. I don't think I can give you exact statistics on like, depending on how sick a kid got, like how severe their rickets was to begin with. At what point do you need to intervene? I mean, obviously, the earlier the better. But supplementation or fortification to kind of prevent rickets is effective. And we have seen that kind of epidemiologically as well. Importantly, vitamin D deficiency isn't the pure and only cause of rickets. There are various other genetic or enzyme-related disorders that can cause rickets or can cause severe vitamin D deficiency even apart from like a nutritional deficiency, if that makes sense. But those tend to be more rare. So the most common cause of rickets overall is nutritional deficiency of vitamin D and or calcium, but calcium because of vitamin D, if that makes sense. Now, when it comes to adults, because we can also be deficient in vitamin D, severe vitamin D deficiency results in osteomalacia, which I mentioned already. This is a process of demineralization of the bone. Importantly, this is not the same thing as osteoporosis, which more people have probably heard of osteoporosis. Now, the risk of osteoporosis may also be increased with vitamin D deficiency, but osteomalacia is a process that's actually interfering with the bone mineralization itself. So that means that in osteomalacia, we see a change in the amount of mineralized, ossified, calcified bone compared to the amount of bone matrix or non-calcified bone. Whereas osteoporosis, which can happen from calcium deficiency that's not related to vitamin D, as well as vitamin D deficiency and other things like just aging. Osteoporosis is probably a whole episode in and of itself. But this is a decrease in overall bone mass, but with normal ratios of mineralized to bone matrix bone. That makes sense?
Yes. Okay.
Both of these things, osteoporosis and osteomalacia, can increase the risk of fractures. They both can coexist as well. So fun. But osteomalacia, you can think of, at least the way that I've been thinking of it, is kind of like the same process as rickets in kids, but with bones that have already been formed. So it's not just the growth that's being affected, but it's the remodeling of the larger, especially large and long bones that tends to be the most affected. So in terms of symptoms, what we can see with osteomalacia is actually a lot of bone pain. Osteoporosis is a painless process. Osteomalacia can be quite painful. And vitamin D deficiency and osteomalacia can also cause a lot of muscle pain and muscle weakness because our skeletal muscles also have vitamin D receptors. And those two things together can increase the risk of falls and therefore fractures.
Wow.
I know.
Okay, and that's still just like one part of the vitamin D story.
Yeah. My next sentence is, we're not done yet. Yeah, we're not. Because that's just the skeletal manifestations.
Yeah.
Vitamin D receptors are found in our brain, in the prostate, in the breast tissue, colon tissue, immune cells. Calcitriol, the active form of vitamin D, has effects on more than 200 genes that are involved in everything from cellular proliferation to apoptosis and angiogenesis, that's blood vessel formation. It is an immune modulator. Like the list goes on and on and on. And we are really still learning the extent to which vitamin D has extraskeletal effects. So when it comes to severe, especially severe vitamin D deficiency, rickets and osteomalacia historically have been the two biggest diseases that we see. But when it comes to deficiency, or what some people call insufficiency, we actually have a lot of epidemiological evidence that vitamin D deficiency or insufficiency is also associated, I can see your face and I can't wait to talk about it, but it's also associated with an increased risk of various cancers, potentially with higher overall mortality. It's associated with various autoimmune diseases, including MS, type 1 diabetes. The risk of cardiovascular disease is increased with vitamin D deficiency, not to mention things like chronic fatigue syndrome and fibromyalgia that we still just don't understand. There are a lot of things that epidemiologically are associated with vitamin D deficiency or with having low levels of vitamin D. But that doesn't mean that we have the slightest clue yet if these relationships are causal or if they might be consequential. Like, is vitamin D just a consequence of these various diseases, disorders, conditions? Or what any of the mechanisms actually are.
Or if it's not mechanistic, but just an indicator of something else.
Right.
Or many other things.
Yeah. Yep.
Yeah. There's a lot that we could get into in that realm of things. And I think it's a little bit frustrating sometimes, I think, to see these studies that look at vitamin D, one measure of one thing, and then something like cardiovascular disease, as if vitamin D will hold all the answers to all of the things. And vitamin D is clearly very important, but I feel like we are still so far from understanding not the individual role that it plays in different tissues or in different organs, but how that fits into the bigger picture of health and disease.
1,000%. I agree.
I have a couple of questions.
Okay, great.
The first one is about insufficiency versus deficiency.
Ooh, versus severe deficiency versus sufficient versus, oh my gosh, Sharon.
Yeah.
Yeah, listen. I have questions too. It's like, you would think it's not that difficult, but it is, in fact, that difficult to answer that question. And I'm going to give you some numbers here, so don't worry. But the exact numbers that you choose to use to define sufficient in vitamin D versus deficient versus severe deficiency. And it seems like some groups like to say insufficient versus deficient, and some groups say like sufficient, deficient, severely deficient. And depending on which paper you read or which consensus statement you read, the laboratory values are going to vary just a little bit. But we at least have some like generalities here. Many groups define sufficient, like you have enough vitamin D. And remember that we are measuring 25 OH vitamin D, which is the one that is made in our liver, regardless of whether the initial vitamin D came from a plant or your milk or a supplement or your skin that you made, okay? And it's not the active form that's made in our kidneys. So sufficient, most places define it as greater than 20 nanograms per milliliter or 50 nanomoles per liter. Then they would define insufficient as between 12 and 20 nanograms per mil or 30 to 50 nanomoles per liter. Some places, instead of saying insufficient, say deficient for that category. And then they would say deficiency or severe deficiency as less than 12 nanograms per mil or 30 nanomoles per liter. The lab where I work and some consensus statements and some societies flag anything less than 20 nanograms per mil as deficient. So it's like a higher threshold for calling something deficient. And anything between 21 and 30 nanograms per mil insufficient. So basically it's raising it, saying that you should have at least 30 nanograms per mil or 75 nanomoles per liter to actually be sufficient in vitamin D.
Okay.
I know those numbers yeah.
Well, okay. I have two more questions.
Okay.
This is follow-ups now. So you mentioned that when we measure vitamin D levels, we are measuring the one that has a longer half-life in the body. It lasts longer in the body.
Yeah.
So let's say I go in and my vitamin D level is 20. How long has it been 20?
Ooh, that's a really good question. I don't know.
Okay.
But it definitely does fade with time. For example, if you measure a population at the end of winter, inevitably their vitamin D levels are going to be significantly lower than that same exact population with no changes at the end of summer.
Right.
But I don't have an exact timeline for you.
And then my other question is, and maybe this is too big of a question, but how were these categories established? How was baseline, how was 30 decided to be the cutoff point for good versus bad levels of vitamin D?
That is a spicy question, Erin.
Yeah, I think that it might be.
I can tell you that 12, that number that is often cited as deficient or severely deficient, that's based on rickets and osteomalacia.
Okay.
So that's based on risk specifically for rickets and osteomalacia. Above that, there's not, I don't think, great data. And that is why there is still controversy. Is it 20? Is it 30? Is it 50? Is it 75? There is a lot of debate still. There's also some societies that say, no, it actually needs to be even higher.
Yeah.
So, yeah.
Well, speaking of that, we've talked so far about vitamin D deficiency. Is there such thing as the opposite of deficiency? I'm blanking on the word.
Toxicity?
There we go.
Absolutely, Erin. There certainly is. In terms of lab values, we would categorize it as greater than 100 to 150 nanograms per mil. That's usually that somewhere in that range, depending on the lab, is what's considered toxic or at risk of toxicity. What does that mean? I don't know.
Yeah.
What does it look like if you have vitamin D toxicity? I will say that toxicity of vitamin D is exceedingly rare. Interestingly, even though this is a fat-soluble vitamin, which means that we can potentially store quite a bit of it in our fat cells, vitamin D toxicity is generally associated with extremely high supplementation rates, like taking a whole bunch of vitamin D supplements, or in rare cases, genetic mutations that lead to changes in the metabolism of those various phases of vitamin D. So when you have too much vitamin D, it can lead to the opposite problem, logically, and that is hypercalcemia, too much calcium in your blood, which can then go on to affect primarily the kidney and lead to a lot of kidney problems.
Okay.
So once we know what our lab values are supposed to look like, the natural next question is how do we get enough vitamin D? Or how do we make enough vitamin D? Or who is at risk for not having enough vitamin D, for having low levels of vitamin D? Vitamin D deficiency, and we're going to get into a lot of this in the epidemiology section, it has been on the rise for decades now across the globe. There are a number of different things that can contribute to this risk of deficiency, however specific number you define it. Number one is lack of sun exposure, because we primarily are making this in our skin from exposure to UVB radiation. So lack of sun exposure can look like a lot of different things. It can look like living at northern latitudes, where half the year there is simply not enough sun and specifically not enough UVB radiation to physically make enough vitamin D for like half the year or potentially more. That's one way you cannot get enough sun.
Mm-hmm.
It also can mean wearing sunscreen all the time. Or covering your body in clothing to protect it from the sun, or for whatever reason that we wear clothing. And I just want to say that that's important because skin cancer is also very real.
Mm-hmm.
So,
yes.
okay. It could also mean more pigmentation in the skin. Melanin is protective to a certain degree against UV rays, and so it reduces the amount of UVB that's available to cause the reaction to make vitamin D. So that's another way you can have less vitamin D available. It also can just be not being outdoors very much at all and being exposed to the sun, even in places that have adequate sunlight for most of the year.
Mm-hmm.
But besides sunlight, this is also a micronutrient. It's a vitamin. And it turns out that we get very little vitamin D in our diets, especially as we eat not a lot of fish and fatty fish oils, which I don't know, maybe like people used to eat more of those.
Well, not even just fish oils, but specifically fish liver oils. Yeah.
But fatty fish in general.
Fatty fish. Yeah.
There are also certain medical conditions that can increase your risk of vitamin D deficiency. Things that result in a lack of absorption in general, like IBD, or after a gastric bypass, or from other conditions that might make it difficult for us to convert to active vitamin D, like, for example, chronic kidney disease.
Okay.
And then another important and very interesting aspect of risk of vitamin D deficiency is higher body fat mass. So vitamin D is a fat-soluble vitamin, which means that it is stored in our fat. It gets distributed into our fat tissue. In the case of having higher fat mass, higher adipose tissue, this vitamin D gets so well distributed into that tissue, it's not actually very readily available for use in our bodies. So you can see a relative vitamin D deficiency in those cases, which I think is very interesting.
Mm-hmm.
So there are a lot of different things that can contribute to the risk of vitamin D deficiency. It's almost never just one thing.
This story is just the most simple thing in the world. It's very clear.
Very clear.
Yeah.
Mm-hmm.
Not complex at all.
Another thing that's really clear is recommended daily allowances.
Oh, yeah. Super clear.
I'm not even going to mention what they are because they're so varied, Erin. They're so varied.
Everyone has a different opinion on it.
Uh-huh. Yeah. And like you asked the question of how did we determine that this level is adequate and this level is insufficient or deficient? I don't think that we really have strong data to say that this is the necessary recommended daily intake. So, nonetheless, you can find it on your public health website of choice for your country. So that, Erin, is pretty much what I have for the biology of vitamin D.
I mean,
it's a lot.
I learned a lot.
Oh, good.
Yeah.
I'm glad you learned something.
I did. I mean, vitamin D, it is so astonishing.
Yeah.
For how much it is involved in different processes, but we don't understand all of it.
I totally understand why people get really excited about the idea of vitamin D being this, like, maybe not cure-all, but like this thing that's like so important. We've been overlooking it for so long. Like, right. I get that because it's fascinating and it's interesting and it's cool. And depending on the way that you look at data, you could convince yourself that that might be true. But if you look at it another way, you might not.
If you design a study to look for vitamin D differences and as it relates to whatever your disease of choice is, and you have a big enough sample size, you're probably going to find something, but is that meaningful? Is that a good study? These are good questions to ask.
Oh, Erin, I feel like you're going to have some more vitamin T to spill.
Vitamin T, I love it.
Thanks.
Just a little bit more of a soapbox, yeah.
Mm-hmm. Can't wait. Can we get into it? Where did this come from? Like, what's the deal? Evolution? Why do we make it? Why do we still have to eat it?
So glad you asked. I will attempt to answer right after this break. One of the things you asked is, where did this thing come from?
Yeah.
It's a great question. And answering that question will take us back further in time than we've ever gone before, I'm pretty sure.
I feel like that was like an intro to Star Trek.
Because to trace the origins of vitamin D, or when organisms first began to use or produce vitamin D, we have to go back not millions of years, but billions of years.
Yes.
Billions with a B. Yeah.
Ugh.
Vitamin D has been produced or utilized by plants and animals basically since life began. And one paper I read suggested that vitamins D2 and D3 could be as old as 1.2 billion years.
Wow.
Yes.
How fun.
Isn't that amazing?
Yeah.
And they're thought to be this old because the transformation of pre-vitamin D2 or pre-vitamin D3 into D2 and D3 via UVB radiation, that does not require enzymes.
Right.
That transformation.
Yeah.
That's amazing.
I know. I didn't mention that, but it's a non-enzymatic reaction. It's pretty cool.
It's mind-blowing, yeah. And nearly every paper examining the history or evolutionary history of vitamin D mentions at the top that phytoplankton have been producing vitamin D for at least 750 million years.
Wow.
Which is just, yeah. Speaking of phytoplankton, we talked about how cod liver oil is a great source of vitamin D. Well, it's likely that cod liver is packed full of vitamin D because of phytoplankton, which produce tons of vitamin D, and then the concentration of it in the food chain and so on.
Oh, because the cod are eating little phytoplankton.
Or eating things that eat. I don't really know the fish diet of cod.
Brings me back to my marine biology days. I should know.
I mean, I've taken an ichthyology class. I have never taken an entomology class, but I remember nothing. It was a great class, but anyway, we usually think of vitamin D in terms of calcium absorption and bone remodeling or renovation. But the phytoplankton and other organisms producing vitamin D 750 million years ago, they weren't using it to create skeletons, bony skeletons. So what was it used for? Some researchers hypothesize that vitamin D2 and D3 largely serve to protect DNA and proteins from damage due to UVB radiation.
Oh.
Mm-hmm. And that it was only later on, millions of years later on, that the endocrine function and immune function of vitamin D evolved. And then, about 385 million years ago, water-dwelling species began moving onto land. But they encountered a problem that they didn't have to deal with as much in the water. Gravity, yes. Moving around was a much different ballgame on land than it was in water, and some land dwellers underwent changes in their bony skeletons to better support their movement in these new environments, which is where vitamin D's role in calcium absorption came into play.
I can't express to you how excited I am by this story right now. Like, I love it. I
do too. I love a deep time evolutionary story.
It's so good.
It was very fun to read this. I was like, whoa, this is not an era of time that I'm used to thinking in. What's going on? I hope
primordial soup stuff, man.
Yeah. And calcium, of course, was important also for the bony fishes that already existed in aquatic environments, but calcium was more abundant in the water, and so it wasn't as much of a limiting factor.
Ooh, okay.
Given this incredibly deep evolutionary history of vitamin D and how early it emerged, it makes complete sense that it's essential for so many organisms, that it serves so very many purposes, and is involved in so many different pathways. It also then makes sense that most animals can experience vitamin D deficiency. Dogs, as we'll hear later on in the history, other mammals, amphibians, reptiles, birds, vitamin D is fundamental to so much of life on this planet. And it's this vital nature of vitamin D that has led many people to explore its possible role in human evolution, particularly in terms of skin color. Right off the bat, I want to say that I am not familiar enough with the literature of this topic to make any assessments about what is known or commonly accepted about the drivers of skin pigmentation in humans. But one popular hypothesis that you may have heard of is known as the vitamin D hypothesis, or the vitamin D folate hypothesis. This hypothesis states basically that more melanin, i.e. darker skin pigmentation, was selected for when humans evolved around 300,000 years ago in Africa in tropical latitudes, and it evolved to protect from harmful exposure to UV radiation. Then, the hypothesis continues, when humans began to migrate out of Africa around 70 to 90,000 years ago, those that moved to higher latitudes eventually lost melanin to better absorb vitamin D now that UVB levels were lower. This is a common narrative, a very common hypothesis that I saw repeated in nearly every paper that I read about vitamin D. And again, I haven't read enough of this literature to be able to tell you all the bits of evidence there are to support or refute this hypothesis. I did read a recent paper from 2022, that discussed how people residing in Western Europe had darker skin pigmentation from around 40,000 years ago when they arrived until around 8,000 years or so ago. And that's when lighter skin became more common. So for that really long chunk of time, about 32,000 years, humans residing in Northern and Western Europe had darker skin. And the proposed reason for this more recent change in terms of skin pigmentation in that part of the world is that that's around when diet would have shifted to rely more on grain, basically the shift from hunting and gathering to agriculture. So the beginning of the agricultural revolution. But bones from that time and earlier don't, as far as I read, show signs of vitamin D deficiency, which you might expect to see if vitamin D deficiency was such a strong driver.
Right.
Only after, so more recent, the past few thousand years, are skeletal remains found that indicate vitamin D deficiency. And of course, this could be that we just haven't found many remains from earlier times. I don't know. There is some evidence showing that variations in particular parts of some genes are associated with vitamin D synthesis, but these variations don't seem to be linked to skin pigmentation variation or skin pigmentation overall, like mechanistically. And again, there's way more to this field of study if you want to read more. But the reason that I wanted to bring it up was to talk not about variation in vitamin D production in humans, but how we talk about that variation. If vitamin D was a strong driver of skin pigmentation over human evolutionary history, that does not necessarily mean that it can explain everything about health today, particularly health disparities. What do I mean by that? I mean that many medical studies will look at whether a certain outcome, like infection with COVID maybe, or cardiovascular disease, or cancer, or what have you, is associated with vitamin D levels and race, presumably, though not necessarily explicitly stated, as a proxy for skin pigmentation, which is, I think, a problem in and of itself.
Yeah, that's absolutely, like literally entire books have been written
Yeah.
about the problem with that.
Yeah.
Mm-hmm.
And we saw countless of these types of studies during COVID.
Yep.
I remember seeing so many headlines about what role vitamin D may play in susceptibility to infection or infection severity. And if you look on Google Scholar, you can find peer-reviewed article after peer-reviewed article suggesting that racial disparities in COVID infection or COVID mortality could be attributable to vitamin D levels.
That's like...
Not accounting for structural inequalities or even discussing it, not institutionalized racism, nothing, just vitamin D.
Yeah. It's like so problematic.
And, you know, of course, it is very possible that vitamin D does play a role in COVID infection. We know that it's involved in immune function. But the problem that I have with these studies is that at the least, the conclusions drawn are overly simplistic and fail to take into account the myriad of factors that play a role in COVID severity or heart disease. And at the worst, they're not far off from victim blaming. They tell you that you got COVID because your skin color, or because your diet doesn't get you enough vitamin D, or because you don't spend enough time in the sun, or because you have too much body fat. It places the burden solely on the individual rather than on the systems that perpetuate these health disparities in medicine today. This isn't to say that we shouldn't look at vitamin D in health. We absolutely should. But maybe just take a more thoughtful approach to study design, as well as interpretation of results. And this also goes to popular media taking these scientific articles and making a headline that's like, vitamin D will prevent you from dying. Like, I don't know.
I swear that was like an actual headline in the New York Times recently.
Well, vitamin D, is vitamin D the key to immortality?
Yeah. Oh, how did we not mention it in our episode?
Yeah, wow, how about that? But yeah, I mean, keep studying vitamin D, but I think it just needs to be more thinking about why and what we're actually measuring about vitamin D. But looking at vitamin D is important because, like I said at the top, and like we learned in the biology section just now, it is a vital part of life. And so when did humans first recognize it as such?
Ooh, tell me.
The first thing they recognized, of course, was not vitamin D itself, but rather the absence of it. And earliest descriptions date back to ancient Greece, around 110 to 130 CE, as well as ancient China, close to the same period. The first writings generally agreed upon to be about rickets come from Serrano of Ephesus. Quote, "When the infant attempts to sit and to stand, one should help in its movements. For if it is eager to sit up too early and for too long a period, it becomes hunchbacked. If, moreover, it is too prone to stand up and desirous of walking, the legs may become distorted in the regions of the thighs." End quote. After this early description, we have to wait around 1400 years for the next one, which is when in 1554, Theodosius of Bologna wrote about a child, quote, "that could not move or sit, indeed hardly hold its head erect, and which showed in the lower dorsal region both a gibbous and a marked lateral curvature," end quote. This long silence in medical texts about rickets doesn't mean that people weren't experiencing vitamin D deficiency or rickets during that time, and we have archaeological evidence backing that up. Skeletal remains have been found from ancient Rome around the 4th century in France, 16th century Italy, and parts of what is now the UK. And these remains show signs of things like childhood rickets or adult osteomalacia. I don't know if enough of these remains have been found or analyzed to give any sort of prevalence estimate during this time, but that changes as we head into the 17th century. And this is when rickets really begins to pick up steam and doesn't slow down until the 20th century. The word rickets is either said to have an unknown origin, come from the German or Old English word ricken, meaning twisted or to twist, or have its roots in the Greek word rachis, meaning spine, which gave rise to the more medical term rachitis. Wherever it came from, the word rickets first appeared in a 1632 receipt book containing cures for, quote, rickets in children. And then just a couple of years after, in 1634, it makes an appearance on the London Annual Bill of Mortality. That year, 14 deaths were attributed to rickets out of 10,900 deaths total for a population of around 200,000.
Wow. Okay.
Yeah. These London Annual Bills of Mortality are actually quite useful over the next decades in tracing the rise of rickets, especially going into the Industrial Revolution.
Ooh.
Scientific and medical writings focusing on rickets paralleled this increase in incidence of the condition in the British Isles. For instance, a 1640 publication listing botanical cures includes a reference to what may be rickets in the thistle section. Quote, Galen saith that the root and leaves hereof are of a healing quality and good for such persons that have their bodies drawn together by some spasm or convulsion or by some other infirmity, which disease is truly to be called the rickets, which happening sometimes to children doeth so bind them in their nerves, ligaments, and whole structure of their body that it suffereth not to grow or prosper, either in height, strength, or alacrity.
That was like a whole Shakespeare situation.
I know. That's honestly why I included so many of these quotes. So I get to say, beginneth, suffereth, doeth. But most researchers attribute the first clear, incontrovertible descriptions of rickets to either Daniel Whistler, who published a monograph in 1645 while in medical school, titled, quote, Inaugural Medical Disputation on the Disease of English Children, which is popularly termed rickets, or Francis Glisson, an English physician who, in 1650, published a treatise on rickets based on clinical and postmortem experience. Like Whistler, Glisson described the signs and symptoms of the disease pretty well, including the characteristic age of onset. And the suggested treatments that Glisson gave were simple, really. I mean, compared to some of the other things that we've talked about on the podcast. Incisions to draw up bad humors.
Oh, dear.
Blistering, or tying soft wool around limbs to prevent blood flow.
Oh, gosh. Okay.
Suspension was also thrown into the mix, particularly for infants.
Well, I'm sorry. What?
Suspension. Like you would suspend them.
What does that mean?
You would just suspend them. You fold in the cheese.
I can't understand what that means.
Okay, I imagine it's like one of those things that I don't know if people still use them, but you like put a kid in like a doorway and it's like one of those suspend things.
Like a bouncy thing?
A bouncy thing. So they don't have to put weight on their limbs, I assume, is the idea.
Holding them?
Except like you've got things to do. You need to create a contraption for suspending your baby.
I can't. Okay, suspension. I just don't even. Okay. Okay, cool.
Yeah. With this incredible rise in rickets cases, people must have been wondering what on earth caused it. But again, the explanations are fairly mundane. According to Glisson, it was neither heritable nor contagious, but that it was caused by, quote, cold distemper that is moist and consisting of penury or paucity of and stupefaction of spirits.
Yeah, that's logical.
That's the way things were. The world would have to wait another 250 years to learn what ultimately caused rickets. And in the meantime, prevalence of this condition would grow and grow and grow, especially in North America and Northern Europe, particularly Great Britain, to the point where it earned the nickname the English disease. And to what do we owe this massive increase in vitamin D deficiency? The Industrial Revolution. From around the mid-18th century to the mid-19th century, people in North America, Europe, and Great Britain began moving in large numbers from the rural countryside to cities, often with bad air pollution, where many of them lived in crowded conditions. The increase in specialized labor and growth of factories meant that people were spending their days indoors working. And that, combined with the change in diet, bread taking the place of dairy, and the reduction in air quality, led to lower calcium intake, lower vitamin D production via both diet and lower exposure to UVB, and thus higher cases of rickets and overall vitamin D deficiency.
Mm-hmm.
No one during the Industrial Revolution was completely exempt from this drop in vitamin D levels, but rickets did tend to happen more commonly in cities and among those earning lower incomes. Over this period, rickets cases grew to unimaginable levels. A physician published a report of infants aged 18 months or less that had died in 1909. I don't know how many were in this report, but he reported that 96% of those infants had rickets at autopsy.
Wow.
96%.
Right. So even if it wasn't that rickets is why they died, like every kid had rickets to some degree.
Yes. Yeah.
Oy.
Despite the incredibly high prevalence of this disease, late 19th century physicians still couldn't explain why it happened and to whom. But they wouldn't have to wait too much longer, as research into diet and micronutrients began to transform our understanding of what exactly was in the food that we ate and how those components sustained life. By the late 1800s, scientists had started digging into the question of what a diet should contain in order to maintain health. And many experiments were carried out to see what proportion of carbohydrates, fats, proteins, and salts were needed for animals to survive and thrive, importantly. But what these scientists were often finding in these experiments using very restricted diets was that even though the caloric needs of these animals were being met, the animals were still dying or failing to thrive. Something was clearly missing. And so researchers set out to find that missing piece of the puzzle, which, of course, turned out to be not one piece, but many. And I feel like I've said that exact phrase on the podcast before. It is now ringing like I'm experiencing deja vu, but yeah.
Maybe it was in folate.
It could have been in folate, could have been in vitamin C, could have been, yep. Over the next decades, into the early 1900s, researchers began linking diet with human diseases. Beriberi cured by including the hulls of rice, scurvy by adding citrus or sauerkraut, xerophthalmia by incorporating butterfat or cod liver oil. This pattern, where certain diseases were cured by certain foods, suggested to scientists that these foods contained some sort of micronutrient whose deficiency was behind the signs and symptoms that they observed. And that given the wide array of signs and symptoms, and that different foods cured different diseases, there were likely many micronutrients. I know we've talked about this before on the podcast, but I just think this history of discovery is so fascinating.
It's so fun. It's so fun.
It is. And one by one, researchers were finding these vitamins and they were given names, starting with A in 1913. And researchers began to uncover more about their biochemistry. Side note, I know that someday we'll probably do a vitamin A episode, but I just wanted to include in here so that I don't forget that I have always read that it was a researcher named McCollum who started this alphabetical naming system, but it was actually his master's student, Cornelia Kennedy, who first used A and B.
Love that.
Love it. Yep. Anyway, research into vitamin discovery was well underway by the 1910s when Sir Edward Mellanby decided that he might like to dip his toe into the vitamin waters. In 1918, he set out to induce rickets experimentally in his chosen study animal, puppies. He took puppies between the ages of 5 and 8 weeks old and exposed them to one of 4 limited diets. Diets like only milk, rice, oatmeal, and salt, or just milk and bread. He reportedly based these diets off of what was commonly consumed by people earning lower income in Great Britain. And these diets were maybe thought to contribute to the high prevalence of rickets.
Okay.
He also crucially kept the puppies indoors the entire time.
Okay.
Unsurprisingly, I think to us anyway, from this perspective in the future, the puppies developed rickets, and Mellanby began experimenting with food to see if any particular item could effectively treat it. Among the foods he tried were cod liver oil, butter, and whole milk. Things that we know today are good sources of vitamin D, but at the time were known to be rich in fat-soluble vitamin A, which had already been found by that point. These foods appeared to relieve the symptoms of rickets, which led Mellanby to conclude that, quote, "It therefore seems probable that the cause of rickets is a diminished intake of an anti-ricketic factor, which is either fat-soluble A or has a somewhat similar distribution to fat-soluble A." Pretty good conclusion. And this experiment marked a pretty big step forward for rickets research. Number one, because it showed that rickets was likely caused by a dietary deficiency, or at least could be treated by diet. And number two, it demonstrated how rickets could be intentionally induced for scientific study purposes. But there were still at least two big things to be figured out: detangling vitamins A and D, and understanding the role of ultraviolet light. Before I get into that, though, I want to take a step back in time, because Mellanby didn't come up with these ideas all on his own. Where, for instance, did he get the idea to treat rickets with cod liver oil?
Right.
As I mentioned, it had been used successfully to treat xerophthalmia caused by vitamin A deficiency, so maybe he got it from there. Or maybe he got it from D. Shute, who in 1824 recommended it for treatment of rickets.
Sorry, did you say Dwight Schrute?
Yeah, Dwight Schrute. Or maybe he got it from Bland Sutton, who in 1889 used it along with crushed bone dust to treat lion cubs with rickets at the London Zoo. Or from Casimir Funk, who wrote in 1914, 5 years before Mellanby's experiment, that, quote, "It is very probable that rickets occurs only while certain substances in the diet essential for normal metabolism are lacking or are supplied in insufficient amounts. The substances occur in good breast milk, also in cod liver oil, but are lacking in sterilized milk and cereals." Or perhaps Mellanby, and probably most of the people I just listed, got the idea because cod liver oil had long been a folk remedy for rickets, like for a very long time, especially for those living along the coast in Great Britain. Which I kind of love, when like this thing that is like, oh, take cod liver oil, it will cure your whatever, it will cure your, and then it's like, oh no, but it does.
It actually does.
Yeah.
It has an incredible amount of vitamin D.
Yeah.
But also, like, what's up with cod liver oil? Like, who made it in the first place? And why were they like, let me take this in my mouth?
I mean, yeah, the whole history of cod liver oil, I have a paper on it that I will post, but it goes back to ancient Greece. I think Hippocrates wrote about dolphin liver oil, which I don't know the content of vitamin D.
Okay.
But it's been really for hundreds, if not thousands of years, it's been a very common.
How interesting.
Yeah, medicinal thing.
Yeah.
I think it was also used for many other purposes, not just like medically.
Oh, yeah.
Too.
Yeah.
However Mellanby got the idea, though, cod liver oil and milk seemed to work wonders for rickets, and this was clearly shown in humans in a 1922 landmark investigation by Harriet Chick and co-authors, who used these to treat malnourished children with rickets in a clinic in post-World War I Vienna. Chick will come back into the story later, but first let's get back into the steps of vitamin D discovery, starting with detangling A and D. To test whether rickets was caused by vitamin A deficiency or something else in cod liver oil, McCollum, who is the person who first discovered vitamin A, and his colleagues destroyed vitamin A in cod liver oil through like heating or aeration. And then they used the resulting substance to treat rickets. And sure enough, it worked. And so they concluded that this was a new vitamin, the fourth to be discovered, hence vitamin D, and that it was likely involved in bone growth. And around this time, other researchers began to shine a light on the role of light, particularly sunlight, I couldn't resist, as a treatment for rickets. Harriet Chick noticed that rickets seemed to be seasonal, appearing mostly in the winter months, and wondered if UV irradiation via lamps and sunlight could work as treatment and prevention for rickets. It certainly did, and was as effective as cod liver oil.
Ooh.
This is actually, I'm thinking of this now. So one of the things that I didn't include in here was the importance of the development of x-rays in terms of diagnosing and understanding the extent to which people had vitamin D deficiencies.
Right, to be able to look at their bones.
Exactly. And that kind of really helped understanding the scope of the problem. But as we talked about in our radiation episode, people thought radiation was also this huge healing thing around that time. And so they were like, drink uranium, whatever. And so I wonder if UV irradiation and vitamin D, that hype around radiation contributed to that in any way.
Yeah,
I don't know.
That's interesting to think about. Ooh.
Yeah. But I will say that people had long believed that sunlight could treat rickets. But this study done by Chick was one of the first scientific studies to demonstrate it clearly. And at nearly the same time that Chick was employing those UV lamps, a researcher named Holczynski was also working in Vienna and demonstrated the same thing. And I can't help but think of how strange this would have seemed, right? It blew my mind when I learned, I don't know when, that we make vitamin D from sun.
I know.
It still is amazing to me. And so it must have been really strange to think wait a second. So here's this thing, this vitamin that we find in incredible amounts in cod liver oil, but then also sunlight can help us make it. What is going on here? And this question drew the attention of several researchers, Harry Goldblatt and Catherine Soames at the Lister Institute, and Harry Steenbach at the University of Wisconsin. Goldblatt and Soames carried out what sounds like a fairly gruesome experiment. First, they fed rats on a diet that made them develop rickets. Okay. Then they killed those rats, took out their livers, and irradiated them. Still okay. Then they ground up those livers and fed them to other rats with rickets.
Yeah, that seems...
okay. Yeah, that's the part. Yeah.
Mm-hmm.
But, hey, no more rickets.
What?
Uh-huh.
Okay.
I know, that was exactly my reaction. And Steenbach did something similar, minus the forced cannibalism. So previously, he had worked with goats that showed calcium loss when living indoors in the winter without much sunlight. And so he wondered if that same lack of sunlight could be causing the skeletal changes in rats with rickets via vitamin D deficiency. To test this, he irradiated the rats, their food, and the air in their cages to see if there was any improvement. There wasn't with the irradiated air, but definitely there was when the food or the rats themselves were irradiated. Hess and Weinstock followed up these experiments by Goldblatt, Soames, and Steenbach with yet another grisly experiment. They induced rickets in rats, irradiated some of their skin, but left other parts untouched, and then fed that skin to other rats with rickets. Those that were fed the irradiated skin of their brethren got better, but those that were fed the non-irradiated skin did not.
It's just so weirdly specific. I have nothing.
Well, but I think it's kind of amazing in that it showed the importance of skin in vitamin D production, and skin as an organ rather than just a mere protective covering, quote unquote, is the phrase that they had used. And that's I think at that time, maybe what it was largely thought to be.
Right. But skin is doing something.
It's doing something.
Yeah.
So I don't know.
Cool.
I think that's kind of cool. I mean, not the forced cannibalism part again, but like
Right. Yeah.
skin. Once the role of sunlight in vitamin D production became clear, all that was left to do was characterize the nature of vitamin D, what its chemical structure was, how it functioned, the physiological processes it was involved in, just the simple stuff. And throughout the 1930s and 1940s, researchers filled in these knowledge gaps about vitamin D, differentiating D2 and D3, describing their chemical structures. Nobel Prize winner Adolf Windaus played a large role in this, showing that cod liver oil contained D3, that vitamin D was a steroid, and revealing the detailed structure of vitamin D3 via X-ray crystallography, which was done in 1948 by Dr. Dorothy Crowfoot Hodgkin, Nobel Prize winner in chemistry, whom we've mentioned more than once on this podcast. We love X-ray crystallography. The rest of the 20th century was filled with further important developments in our understanding of vitamin D. But for public health officials, the big chunks of knowledge were already there in the early decades of the 1900s that allowed them to enact measures reducing vitamin D deficiency, namely vitamin D supplementation through food or sunlight to help treat and prevent rickets and other consequences of vitamin D deficiency. Many programs supplementing children's diets with vitamin D had been underway since the late 1910s, and the widespread fortification of food with vitamin D, especially in milk and infant formula, led to rickets nearly being eliminated in many places. But nearly is not the same thing as completely, and rickets is just one aspect of vitamin D deficiency.
Yep.
And I think that, as you mentioned, Erin, we are kind of increasingly becoming more vitamin D deficient.
Mm-hmm.
And so I'll turn it over to you now to tell me a little bit more about that.
Ooh, I can't wait to. Let's take a quick break and then I'll get into it. Really quick, before I jump into the epidemiology, I wanted to just mention, because I thought of it as you were mentioning, that they used milk in these historical studies to treat rickets, as a couple of things. One is that milk is actually not high in vitamin D, but it is fortified with vitamin D in the US and in a lot of countries in Europe, though I'm pretty sure not in the UK currently. It's a whole nother thing. And human breast milk is also very low in vitamin D. It has very poor transfer into breast milk, in human breast milk. And so breastfed babies are actually at high risk in vitamin D deficiency, which I didn't mention when I was mentioning all the other ways that you can become vitamin D deficient.
That's very interesting.
It's especially when you think about it evolutionarily, but, you know, if we just were exposed to a lot more sunlight, usually, makes sense. So anyways.
Oh, that was actually a question that I was going to ask in biology, and then I forgot. How quickly do we make vitamin D from sun exposure?
Oh, that's such a fun question. I have some numbers on that, actually. There's some estimates that, for example, and this, of course, will depend on like the day and the season and the latitude and et cetera. But exposure of your arms and legs for 5 to 30 minutes between 10 a.m. and 3 p.m. twice a week usually makes enough that people don't become deficient. That was one estimate I saw. Another one is that exposure to where your skin gets just a little bit red, not recommended, skin cancer, etc., while wearing only a bathing suit is the equivalent of ingesting about 20,000 international units of vitamin D.
Whoa.
I know. Isn't that interesting?
Wow.
Yeah. So it can kind of vary, but yeah. Okay, anyways, this is supposed to be the epidemiology section. Let me tell you. Since, like I laid out in the biology section, the definitions that you use for deficiency and insufficiency are going to vary. And so, unsurprisingly, our estimates for population level numbers of deficiency or insufficiency, they vary, okay? They're not great, but I do actually have quite a lot of numbers for you. Looking at deficiency as defined as less than 20 nanograms per mil or 50 nanomoles per liter, which is kind of the most common definition. Rates of vitamin D deficiency are as high as 24% in the US, 37% in Canada, and 40% in Europe, depending on what paper you look at. Some studies even say that up to 100% of elderly adults might be deficient. That seems excessive.
Whoa.
If we look at severe deficiency, or what in some cases is just defined as deficiency, if the other version is just insufficiency, and that is less than 12 nanograms per mil or 30 nanomoles per liter, that's estimated to be at around 6% in the US, 7.4% in Canada, and 13% in Europe. And now these are all very big places, and these are all very big populations, and that's not even including so much of the rest of the world. I do have numbers as well for India, Tunisia, Afghanistan. These just happen to be some places that have data in the papers that I read. There, those estimates tend to be around 20% or more of the population that may be deficient, and I don't have numbers for severely deficient. Globally, what this adds up to is that it's estimated that 1 billion people worldwide have vitamin D deficiency or insufficiency, that less than 20 number. And of course, this is going to be higher in certain subpopulations as well, like kidney failure or with severe liver disease.
Mm-hmm. Right.
When it comes to looking at the diseases that we know are caused by vitamin D deficiency, specifically rickets, the numbers are thankfully much less dire than they once were. In a 2017 review looking at rickets, the case rates were estimated at between 3 and 27 cases per 100,000 individuals in the US and in Europe.
That's higher than I thought.
It's higher, but it's a decrease from an estimated prevalence as high as 25%, or like you even saw, Erin, 96% of kids who died.
Yeah.
And 25% of kids overall in the late 1800s.
Yeah.
So that's massive. A lot of that in the US and Europe is likely in part due to fortification programs, like you mentioned, with formula and milk. All milks in the US, including plant-based milks, and orange juice, weirdly, is fortified with vitamin D, as well as supplementation, the recommendation for supplementation in like breastfed infants and things like that. So we know that those kind of programs can improve this risk of severe vitamin D deficiency, can reduce the prevalence of things like rickets. Osteomalacia in adults, I had a really hard time finding data on, probably because it's just widely under-recognized in general. Mm-hmm. Despite all of that, like good news, we still know that those numbers of overall deficiency are pretty high.
Yeah, they are.
Right? Like
they are.
20 to 40%, like that's really high numbers. So then this is where things get a little weird and kind of fun. Okay.
My favorite two adjectives put together.
Because we know that deficiency, whatever specific number you choose to use to define it, is a problem. We know that there's epidemiological data to suggest that it's associated with a lot of risky, scary-sounding things, cancers, cardiovascular disease, et cetera, et cetera. There's these associations. Because of this, because of those two things, there are a lot of spheres, especially on the interwebs.
Oh, the interwebs.
That will say that everyone needs to be supplementing. We all need to be taking supplements, every one of us. And the thing is, a lot of studies have looked at this. A lot of studies in the recent 10 years or so, since about 2011, when a big Institute of Medicine report came out that said, here's the recommended daily intakes. Here's how much vitamin D we need to be getting to hit these thresholds of 20 nanograms per mil, across the board. They were also like, hey, we also need a lot of better research to figure out, do we need supplementation widespread, or are we doing okay with just our diets and the fortification programs that exist? So a lot of studies have come out since that 2011 paper that have tried to look at this, specifically looking at widespread supplementation with vitamin D supplements at various levels, 1,000 a day, 2,000 a day, 400 a day, whatever, without checking first if someone is deficient or not for them to be in the study, okay? Just let's take a group. Yeah, let's take a group of people. Let's give them vitamin D and see what happens. And most all of that data, whether in individual studies or in meta-analyses, does not improve outcomes. So there is data to suggest that this widespread supplementation, without checking if people are deficient before they're in the study, does not reduce the risk of fractures, does not reduce the risk of low bone mass or osteoporosis. Those are just the skeletal things. It also doesn't have any evidence for prevention of cardiovascular disease, prevention of falls, improvement in cognitive function, prevention of stroke, prevention of all-cause mortality or cardiovascular mortality. And this is all super fascinating to me.
It's interesting. I don't know if I love that they didn't test people's baseline vitamin D levels, but
that is kind of part of the questions, right? Do we need widespread supplementation?
Yeah.
Well, and where it gets even more interesting is that there's also been a really big push in the literature when it comes to even screening for vitamin D deficiency. Essentially looking at the costs to healthcare systems to test everybody for vitamin D deficiency, either annually or like on some frequency, just as a routine lab with no real indication, like no symptom that you're worried about, no specific risk factor like kidney disease or whatever, but just like check it on everybody. That happens in a lot of places as a matter of routine. And there's not a lot of data to suggest that it's beneficial, especially when you look at what the supplementation studies also show, that like widespread supplementation also isn't helpful. And yet, at the same time, we know that deficiency is probably underestimated. So it's just, it's really interesting.
We do not have it figured out.
No, we don't. And I do think that part of this comes back to what I mentioned when I said that while we have a lot of these epidemiological associations between low vitamin D status and all of these various diseases or outcomes, we do not have evidence of these relationships being causal.
Mm-hmm.
And if they're not causal, then there isn't a reason why supplementation would improve any of those outcomes. We wouldn't expect it.
Right.
So are they a consequence? Is vitamin D deficiency some kind of early or easily identified consequence of various diseases, disorders, conditions?
Mm-hmm. I love this. It's really good food for thought.
It is.
What does vitamin D mean beyond vitamin D?
Yeah, and it's so fun to read about because the drama when you read some of these articles.
Oh, gosh.
You know what it felt like, Erin? This is very niche, but it felt like the dilution effect for disease ecologists. People are just like so passionate. Everyone, like, people are like, everyone is deficient. You need to be supplementing with everything. And people are like, no, never take a supplement. Like, it's just.
People have very strong feelings about this.
Such strong feelings, which I feel like always tells you something. You know, when people are so steadfast and like, this is the one and only way, like,
It probably means that the truth lies somewhere in the middle.
Exactly. I think that what it means is that the truth lies somewhere in vitamin D is an important substance that is necessary to human life and function, and a lot of our different human functions. And we need to know more about it. And there's a lot of people in the world who probably aren't getting enough of it. Either they're not making enough of it, or they're not getting enough of it in their diet, or some combination thereof.
Yeah, sums it up.
But that's vitamin D. There's a lot more there. There's cool stuff like you mentioned the vitamin D in COVID. There's a lot of really interesting research being done on vitamin D and like severe illness and sepsis, severe infection in general.
Mm-hmm.
Super interesting stuff. No answers.
Of course not.
But really interesting.
And speaking of really interesting things, in case you want to read more, should we do sources?
Yeah, we absolutely need to.
Okay. I have many, and I just want to shout out two in particular. All the rest will be on our website. One is by Carlberg from 2022 called Vitamin D in the Context of Evolution. And then in terms of the history of vitamin D, one paper, there were many, but one paper I really liked was by Raja Kumar from 2003 called Vitamin D, Cod Liver Oil, Sunlight, and Rickets.
Excellent. I also had a number of papers for this episode. A few of my favorites just about the biology and kind of current epidemiology of vitamin D. One was just called Vitamin D Deficiency in the New England Journal of Medicine. That was a very useful one. Another was the Diagnosis and Management of Vitamin D Deficiency that was published in BMJ back in 2010, a little older. And then, of course, there's those really fun papers looking at vitamin D supplementation and all of the various things. Some of those are coming from the VITAL study, VITAL. We will post the list of all of our sources from this episode and every one of our episodes on our website, thispodcastwillkillyou.com.
We sure will. A big thank you again to Brittany for sharing your firsthand account. Thanks so much for being willing to do that.
Yeah, thank you. And thank you also to Liana Squillaci for your amazing audio mixing.
And speaking of audio, thank you to Bloodmobile for providing the music for this episode and all of our episodes.
Thank you to the Exactly Right Network.
And thank you to you, listeners. We hope that you liked this deep dive into vitamin D. Who knew it would be so very deep?
Tell us if you're really mad at our
if you're like, but where's the truth?
And of course, a special shout out to our patrons. Thank you so, so much for your support. We love it. It means the most.
It really does. Thank you. Okay, well, until next time, wash your hands.
You filthy animals.
Listen, follow, leave us a review on Amazon Music, Apple Podcasts, or wherever you get your podcasts. Hey, Prime members, did you know you can listen to This Podcast Will Kill You early and ad-free on Amazon Music? Download the Amazon Music app today. You can support This Podcast Will Kill You by filling out a survey at Wondery.com/survey.
I keep getting distracted. I'm supposed to be studying for midterms, but I'm learning way more interesting stuff listening to podcasts. Have you heard all the good ones on Amazon Music? Okay, for example, I now know all about the sex lives of people during the Middle Ages, and this is crazy, they were getting way more action than we do now. Or, like how astronauts use the bathroom in space. Yeah, you don't want to know. Oh, and how blood, sweat, and tears aren't enough to win a championship. There's a ton of advanced analytics. Who knew sports required so much math? And speaking of math, I'm learning how to make my money work for me so I can retire young. That one's pretty useful, because I'd never have to worry about midterms again. Hey, your girl can dream, right? Until then, I guess I'll keep listening to podcasts and daydreaming about what could be. Amazon Music. All the music and top podcasts ad-free. Now included with Prime.